Yes.
Any problem is fine.
You said from 4.5?
Yes.
Okay. So you're talking about problems like these? Finding the definite and indefinite?
Yeah.
Okay. But tell me which problem, if you watch the video, maybe you have these problems already. You choose. Just choose any problem that you had difficulties with. That's the best. Or maybe somebody else wants to suggest. It doesn't matter.
Could you do number 6?
Yes, and that's from 4.5?
Yes.
Okay, number 6. 4.5, number 6. That is the integral from. So this is number 6. The integral from, is this the 3t to the 4th plus 2 times t cubed dt?
Yeah, that's it.
Perfect. So can anyone give us an idea which substitution we should work on, or anybody suggest any substitution? Please take notes, because that's the only way I can tell whether you're here or not. So please take notes, because I would like to see your notes. Remember, I give points at the end of the semester, but if I call somebody and I don't hear anything, I don't know if the person is here or not. But you have to take notes and upload them so I can see that you are present. And I send you a file. You don't have to use that one. You can use any blank sheet of paper, but this is what I would like you to upload. Okay, so back to our problem. Can anyone give us a substitution here? I see I'm having trouble with my Wi-Fi and the internet. I'm going to try switch. Okay, very good, no problem. Okay, can anyone give us an idea of a substitution here? Anyone?
Is it 3t to the 4th power plus 2?
Exactly. As long as we can find the differential. What is the differential of this function? Great job.
12t to the 3rd
Yes?
dt?
Yes. So I'm lucky, we're lucky, because I see t to the 3rd dt. It's right here. It's this product. But I don't have the 12. A number or a constant or a factor, I should say, very easy to make up. Multiply by 12 and divide by 12. Another way would be to solve for this, which gives us the exact same answer. So then we have 1 over 12 in front. Can anyone change this integral now in terms of u? No t at all, only u. Anyone, please? It's okay if you're wrong. Can anyone change this integral from this to here? Please, anyone?
Is it u times du over 12?
We already have the 12 outside. Indeed. So this portion is u, this portion is du. And that's it. 1 over 12, u squared over 2 plus a constant c. Since it is an indefinite integral, we must go back to the given variable. So we have 1 over 24. Our u is 3t to the 4th plus 2, everything squared, plus a constant c. And this is it. And that's the final answer for this indefinite integral. Devin, do you feel a little bit better about this? part was more difficult, or?
I would say number 50 was pretty difficult for me.
The number 50 from the book?
Yeah.
Yeah, let's do that. So the same page in the same 4.5,
Yeah, it's 4.5.
and you said number 50. Okay. Number 50, 50? Yeah, sorry, I was looking at 4.4. So let's look at 50. I see. So the integral from 0 to 4 dt divided by 1 plus t. Good. We discussed something similar last time. Can anyone give us a substitution? You can use any letter. Doesn't have to be U, it can be Y, it can be Z, but it cannot be T. It can be X, but not T. Not T.
U.
Yes?
U equals 1 plus T.
1 plus T. What about du? Excellent.
dt.
Yes, because when you differentiate this, you get 1, so it's dt. Nice. So this is the same thing with du. This will be replaced by u. Do not copy the limits of integration. That would be a terrible mistake. So this is the integral from du over u. This is du and this is u. When t is 0, how much is u?
1.
Very good. When t is 4, how much is u?
5.
Very good. So then, which function prime is 1 over u? Which function we differentiate to get 1 over u?
Log.
Yes, indeed. So this is natural log of the absolute value of u. You can say there is no need for the absolute value because you plug in positive numbers. True. So I have natural log 5, but when I plug in when I plug in 1 and I get natural log 1, what do I get? What is that? That's it. These integrals look difficult, but once you practice a little bit, you will feel very comfortable with them. Is there anything else, other questions for me? Anything you'd like to go back to? Any problem from Pearson or a book or anything? Previous class, anything? Anyone? Any questions? Well, at any point in time, I'll be more than happy to stop and go back. Okay. Chapter 5, we're going to look at 2 applications. Applications of chapter 4. What was chapter 4? Of integration. And we only look at 2 sections, 5.1, which is an application, and 5.7, which is a different application of integration. In other words, integrals, right? In 5.1, we're going to look at consumer plus producer surplus. In the last section of chapter 5, we're going to look at differential equations. What is a differential equation? Just to give you an idea, a quick idea, it's an equation that has first derivative, let's say, times y equals 2x. So this is a differential equation. It has derivatives. It has derivatives, or one or more. I can change this and make it even more difficult. First derivative plus the second derivative equals 2x. This is an equation that has derivatives in it. Any equation that has derivatives in it is called differential equation. But of course we're going to start with 5.1. A long time ago in the review chapter, in chapter R, we talked about two things, and I know you remember. We talked about demand and supply, and we also talked about a point where they meet. So this is a demand, and let me use a different color for the supply. Anyone remembers how we call this point?
Equilibrium.
Excellent. So the EP. So we talked about three things. Thank you so much. Demand, supply, equilibrium, point. Excellent. So we're coming back. So the consumer and producer surplus, they're based on demand function, supply function, and the equilibrium point, or maybe other points. So let's start with something called consumer surplus. Okay. In short, consumer surplus. That's the abbreviation that I'm going to use, consumer surplus. Okay, so let's take a look at the function. Of course, a demand function. I'm going to graph the same thing I graphed over there. So this is my demand function. This is number of units, and up here on the y-axis, price per unit. This is not a rate of change or anything like that. It's the price for each unit. Okay. So, how does this work? So let's take a look at this demand function. So this is demand, the demand function. And let's take a look at any point on the demand function. So let's say here. For this price per unit, I'm going to say $5 per unit. We are interested to purchase, let's say, 3 units. If the price goes down from 5, somewhere here, let's say the price is $2 per unit, then we're interested in purchasing 10 units. So at this price, the demand is higher of the number of units. So the price is lower. Let's say the price of coffee. I'm not a coffee drinker, but or tea, whatever you want. So if it's $2 per pound, we are willing to spend 2 times 10, $20, and get 10 pounds. If the price is $5 per unit, we are not interested in going more than buying 3 pounds. How much is the cost? Well, if we buy at $5 per unit, this is the cost. This area. How come? Well, 3 units times the price of 5. So this is the area. Base times height. Base is 3, height is 5. So the area is 15. If we are here, not the equilibrium point, this is a point. So if we're here, this will be our cost, this area. Base times height. Base is 10 times 2. So this area now is 20. Okay, regardless of, I just want you to understand how the curve works. I'm going to choose any of these 2 points to explain what is consumer surplus. We haven't talked about the consumer surplus. We only talked about if the price is this, then we are willing to purchase 3 units, pounds, whatever. If the price is here at 2, we're willing to purchase 10. So just for us to see how the curve works. But I'm going back and I'm going to graph it again. I don't want to put it in there. So this is the demand. Again, this is number of units. And this is price per unit. Okay. Again, I'm going to pick a point. And we already know that our cost is this, whatever. So I'll stick with 3 and 5, it doesn't matter. This area above, right here, this piece, it's not a triangle, it's some area. This is the consumer surplus. What does it mean? Well, we are paying 3 times 5, which is 15. But actually, we are getting something extra that we are not paying for. And this has a dollar sign to it. This area, 5 times 3, is $15. But this is something that we are getting without paying for it. It's a utility, some extra that we are getting. This piece is the consumer surplus. Okay, what do you think I need to do in order to determine this, which is an area? But it's not a particular shape that I can determine. Here I know that the area is 15 because it's a rectangle. And I know that the area of the rectangle is base times height. Base is 3, height is 5. I multiply them, I get 15. But I only want to determine the red area. I don't care for this. I know my cost. But I want to know how much I get the extra, so to speak, if I buy 3 units at 5 per unit, $5 per unit. So I would like you to say, I know how you find the consumer surplus based on chapter 4. Look at this and say, I know how to determine that area. Don't say anything.